All right, today we're going to keep talking about how to prove triangles are congruent. We're going to learn two new theorems, AAS and ASA, but we're actually going to end up combining them and just thinking of it as one theorem. And I'll talk about that in just a minute. So basically, remember when we were talking about what I called the letter theorems? We did SSS, which was side, side, side. We did SAS, which is side, angle, side. And I told you basically every time you see the letter S, it means side. And every time you see the letter A, it means angle. So when we say AAS, that means angle, angle, side. And when we say ASA, that means angle, side, angle. So both of these theorems have two angles and one side the same in each triangle. Now the order is different, because remember when we talked about SAS, we said the letters tell you the order going around the triangle. So our book and most books present this as two separate theorems. So for example, this first one right here, AAS, that means going in order around the triangle, you have one angle, then another angle, then a side, and that's the same in both triangles. Whereas the second one, ASA, that's kind of like our SAS, where the side is in between the angles. It goes angle, then side, then angle, and that's the same in both. But as I mentioned earlier, we're going to end up combining these two into one, and I want to show you why we can do that. So here is an example of ASA triangles. These two triangles that you see right now are congruent by the ASA theorem because in order we have, and I'll mark them in red here to make it stand out, we have this angle is the same in both, then we have this side the same in both, and then we have two marks, so this angle is the same in both. So going in order, it goes angle, side, angle, ASA. And then the same thing here, angle, side, angle. Going in order around the triangle, that's an ASA. Now this is an example of AAS. And I'll mark it up in red again. So in one triangle, I have this angle the same. There's my first A. Then I have this angle, that's another A. Then I have this side is the same, that's my S. So going in order this time around the triangle, it goes AAS instead of ASA. So let's talk about why these are actually the same thing. And that's what this says, even though it popped up behind my camera. It says, why are these actually the same thing? Well, here's why. Because it turns out the third angle is the same in both of these anyways. So one thing we know about triangles, the three angles of a triangle always add up to 180 degrees. So if you think about it, if I put some numbers in here, let's say this angle, angle A right here was 80 degrees. And let's say angle C was 40 degrees. Well, I could find angle B by just adding up and subtracting from 180. Angle B would end up being 60 degrees. Well, if A is the same as D, then D is also 80. And if F is the same as C, it's also 40. And if I add those up and subtract from 180, I get 60 here too. So the idea, and there's actually a name for it, it's called the third angle theorem. It says if two angles of a triangle are the same, two angles of two triangles are the same, the third one automatically also is. So even though it wasn't marked in the picture, I could put 1, 2, 3, 1, 2, 3, because those are both 60. They're both the same. And I could do the same on the other picture without putting numbers in. If I added them up and subtracted from 180, whatever is left over for B, 1, 2, 3, will be the same as E. So the truth is, if you have ASA or AAS, what you actually have is something kind of like this, AAS. You have all three angles and the side. So that's why I'm going to say from now on, I'm not going to really try to tell the difference between ASA and AAS. We're just going to combine it in, and we're going to say if you have any two angles and one side in any order doesn't matter for this one, any two angles in one side of one triangle are the same as two angles in one side of the other triangle, then they're automatically congruent. So here's our summary. As of right now, we have 3 ways to prove that 2 triangles are congruent. And that's what we're doing right now. That's our focus. For our next test, I'm going to give you some triangles and ask you guys to prove they're congruent. Step 1, or method 1, is SSS. And that stands for side, side, side. And that says we don't need to know anything about the angles. If I can show that 3 sides of one triangle are the same as the 3 sides of the other, they're automatically congruent. Then we had SAS, and this is the one that's important, that order matters. It's 2 sides and the angle in between. Going in order in a circle around the triangle, it has to go side, then angle, then side, is the same as side, then angle, then side of the other triangle. And now our new one, I call it AAS/ASA, although I would tell you you can call it either one. Like if it was actually supposed to be an AAS and you wrote ASA, I still give you credit for that, because to me, from now on, those are the same thing. So you can write either one of them, you can write both of them with a slash between it like I did. That's our third theorem, is any 2 A's and an S, basically. Now I will mention to you, there is a 4th way that we're going to learn later that is for right triangles only. We haven't learned it yet, so you don't have to worry about it, but just so you know for the future, there actually is a 4th way. So like if you were studying from the book or you were looking something up online and you saw a theorem called HL, don't worry about that one for now. That's for right triangles only, and we'll learn it a little bit later. So for right now, we're going to focus on our 3-letter theorems, all S's and A's, and these are the ways that you can prove triangles are congruent. So for tomorrow's activity, you guys are going to be doing that. I'm going to give you some triangles. I'm going to say, hey, are these things congruent? Yes or no? You're going to use everything you've learned so far. You're going to use things like reflexive property, vertical angle theorem, maybe parallel line theorems, all those different things to prove different parts of the triangle are congruent. And then you're going to decide whether they are congruent by either SSS, SAS, or ASA/ASA, or AAS.